Okay, the overall design of a database. Again, database means collection of tables. Okay, tables is nothing but it is organized in the form of rows and columns. Again, coming to the database is nothing but collection of interrelated data. Okay, so what is the meaning of schema? It is a overall design. Overall design is nothing but if you observe after creating the table, okay, if I want to view this table means I need to give the description table name. అప్పుడు నాకు కాలమ్స్ ఏమేమి ఇచ్చాను లైక్ రోల్ నెంబర్ ఇచ్చాను బ్రాంచ్ ఇచ్చాను నేమ్ ఇచ్చాను అవి డీటెయిల్స్ చూస్తాయమ్మా ఈ త్రీని మనం ఏమంటామంటే ఈ త్రీ ఫీల్డ్స్ ని స్ట్రక్చర్ ఆఫ్ ఏ స్టూడెంట్ డేటాబేస్ ఇన్ఫర్మేషన్ లోపలైతే ఏవైతే ఉంటాయో ఫీల్డ్స్ అవన్నీ కాదమ్మా స్ట్రక్చర్ ఏంటి ఇక్కడ ఫస్ట్ ఫీల్డ్ నేమ్ ఏంటి రోల్ నంబర్ నెక్స్ట్ ఫీల్డ్ నేమ్ అంటే కాలం నేమ్స్ చెప్తున్నా ఫీల్డ్ ఈజ్ నథింగ్ బట్ కాలం ఓకే రోల్ నంబర్ ఇంకో కాలం నేమ్ ఇంకోటి బ్రాంచ్ ఉంది దీన్ని మనం అనేది స్ట్రక్చర్ ని స్కీమా అంటాం ఓకే స్కీమా ఇస్ నథింగ్ బట్ ద ఓవరాల్ డిజైన్ ఆఫ్ ఎ డేటాబేస్ ఇస్ నథింగ్ బట్ schema. So two types of schemas will be there, physical schema and logical schema. How many types? Two types, physical schema, logical schema. Again, here it is related to the concept of levels of data abstraction. So physical schema is nothing but the database design at physical level is called as physical schema. Again, here comes the concept of physical level. What is physical level? It is the lowest level of abstraction. It deals with how data are stored. Okay, it involves simple data structure. It is also called as storage level. It is also called as database level. Okay, so a database design at physical level is called as a physical schema, right? Next, logical schema is nothing but a database design at logical level. Again, here comes the concept of logical level in data abstraction. What is that one? It deals with what data are stored, what relation among those data. There exists physical data independence. It involves complex data structure. Okay. So two
Exactly.
types of schema. What are the two types of schema? Physical schema and logical schema. Database design at physical level is called as physical schema. Database design at logical level is called as a logical schema, right? So these are the definitions of instances and schema. What is instance?
It is a collection of information stored at particular momentum of a time.
Moment of time is called as an instance. Schema, the overall design or logical
Logical
structure of a
structure.
database. Schema. Two types of schema, physical schema and logical.
Also same.
So we have seen physical data independence, right? What is physical data independence? In logical level, it is a application level where applications do not dependent on the physical level that we call it as a physical data independence. Is it clear? Yes or no?
Yes, ma'am.
Next, data models. Okay.
Yes, madam.
So data model is nothing but it is a basic concept. It is a basic structure of a database. Okay. So here it is a conceptual tool. Okay, which describes four things, mainly four things: data relationship, data semantics, data constraint. Again, we know what is data. What is data?
Types of records are
That
stored.
can be stored, right? That can be stored or recorded. Coming to data relationship, whatever data we have stored, right? That shows the relationship. So see here, if you take roll number is there means we can identify the name. Okay. So what is the relationship here? Name. If I want to view the name, I need roll number. Then only I can identify the name. Why? Because multiple names will exist in the same class, right? To identify a particular person, I need to have the roll number. So here these are interrelated, right? Relationship. These are interrelated. That is what data relationship. Coming to data semantic. What is the semantic is nothing but meaning. Okay, meaning of a particular data is called as a data semantic. Meaning of a particular data is known as a data semantic. Next, last one is data constraints. As I said, constraints are nothing but conditions. What is constraint? Conditions. Conditions of
Condition.
particular data. Okay, like integrity constraint we have maintained that balance should not be null or less than zero, right? So this we call it as a data constraints. You need to remember data model is a collection of four things. What are the four things? Data,
Data,
data
data
relationship,
relationship,
data
data
semantics, data
constraints.
constraints. అర్థమైందమ్మా?
Yes, ma'am.
What about remaining? Only few are responding, only 2%. What about remaining?
Yeah, definitely. Yes, madam.
Yes. ఏమ్మా మీరు చెప్పండి, మీరు చెప్తేనే నేను ప్రొసీడ్ అవుతాను, లేకపోతే నేను మళ్ళీ రిపీట్ చేస్తాను.
Yeah, yeah. It's understood. No doubt so far. Thank you.
Okay. So here there are four types of data models. Okay, four types of data models. First one is relational data model. Second one is entity relationship model. Third one is object based model. Fourth one is semi-structured data model. Okay, how many types? Four types of data models are there. Relational data, entity relationship model, object based model, and semi-structured data model. First one is relational data model. So we are having some advantages of relational data model. For example, see here. So this is a relational model which is having this is a customer file, customer ID, customer name, customer street, city, account number. If you observe here, how many columns are there? 5 columns are available, right? Customer ID, customer name, customer street, city, account number. We call it as a this customer file. Now, in relational model, what will happen, right? So here, from the existing table, I can make into 2 or 3 tables. Okay, what is my point here? From the existing table, I can convert into 2 or 3 tables. Okay, see here how one is customer related file. Okay, so customer related file column names ఏమున్నాయి? Customer ID, customer name, customer street, city. Okay, this is a customer table. Again, second table is account table. Account number, balance is one table. Next, coming to the next one, customer ID and account number is depositor table. So what is the advantage of this relational model? This shows the relationship. With the help of customer table, I can view the account table. Okay, with the help of depositor table, I can view the customer information like that. It shows the relationship. Okay, so here, what is the main advantage of relational model? From the existing table, we can convert into
Two
two
tables.
or tables. What is the
Two
thing
or
here? Relations. It is showing the relations. And one more thing here, RDBMS. What is the full form of RDBMS?
relational database model.
Management system. Okay. So relational database management system is a collection of database. Okay. Relational database management system is a collection of database. Database is a collection of
Records.
tables.
Tables.
Okay. Tables is the collection of fields. Fields
Fields.
is a collection of records.
Record.
Okay. Na? So we can go also vice versa. Records is a collection of fields. Fields is a collection of tables. Tables is a collection of database.
Database.
Database is a collection of RDBMS. Okay.
Yes, ma'am.
So what is meaning of this one? RDBMS is a collection of database. Database is a collection of tables. Tables is a collection of fields. Fields is a collection of
Fields is the collection
records.
of records.
Two advantages I explained in relational model. What are the? From the existing table, we can make the relationship and we can convert into 2 or more tables. And
Tables.
also, RDBMS is collection of tables. These are interrelated things. Okay, that is what relation. It shows the relations. RDBMS is a collection of means it shows the relation between the database and the RDBMS, and also it shows the relation between fields and the database and fields and records. Okay, these are interrelated. Okay, so relational model. Next, what is the second type of model here? Entity relationship model. So, entity relationship. What is the meaning of entity? It is a real world thing or an object. Okay, it is a real world thing or an object. Here, if you observe here, entity relationship model, entities are represented in rectangle box. Example, customer, account. Here, two entities are present in this diagram. Customer and one is account. Okay. So customer ID, customer name, customer street, customer city. These are called as attributes. What are these called as? ID, ID, name,
Person, mute yourself.
street, city. This we call it as a attribute. Coming to the account, how many attributes are there? Two attributes. What are that? Account number, balance. Okay. So one more thing here, relationship. What is relationship here? It is a association between two entities. How many entities are present here in this diagram?
Two.
What are the two?
Customer account.
Hmm. Okay. So customer account. So entity representation is rectangle box. Okay. Entities are represented in rectangle box. If you observe here clearly, customer is one entity, account is other entity. Okay. And coming to the depositor, what is the meaning of depositor is it shows the here if you observe diamond shape is represented, right? For relationship it is represented as a diamond shape or rhombus shape. Okay, so here it is an association between customer and the accountant account. This we call it as a relationship. What is entity? It is a real world thing or an object. Okay. Next, what is relationship? It is an association between two or more entities. We call it as a relationship. Okay. So in next slides, we can see types of entities, types of attributes, types of relationships. Okay. As of now, clear?
Clear, madam.
Yes, ma'am.
Yes, ma'am.
So next one, third type of data model is object-based model. So what is the meaning of object-based model is? So
Property.
object-oriented programming languages like C Sharp, Java, C++, C. Okay, so these are the programs used for nowadays we are going to do the application, web application, right? Designing the web applications. So what the programming languages we are going to use for that
HTML,
to
CSS,
develop a web
JavaScript.
application? HTML, JavaScript, CSS.
JavaScript.
Okay.
Yes,
And
ma'am.
for backend support, we are going to use like MongoDB,
MongoDB.
database like SQL servers. Okay. So coming to the object-based model here, for front end, we are using some of the programming languages like even Java, C Sharp we can use. Okay. So
Yeah.
here in terms of our DBMS, database model equal to ER model plus object oriented polymorphism abstraction.
Abstraction.
ఇంకోటి
Encapsulation.
encapsulation. Okay.
Okay.
So
Yes, ma'am.
object based model equal to ER model. What is ER model? Just now
Entity
I speak
relationship.
about real ER model, right? Entity relationship model plus for backup we have used this ER model, and for front end we are using object oriented features. Okay. See my example, simple example to design a web page. Okay, for front end we are using as a JavaScript or whatever web technology HTML. Okay, for back end support again we need some for storing purpose we need some database, right?
Yes.
Similarly here also object based model equal to object oriented features for front end and back end ER model. Okay, ER models are nothing but why we need to use ER model means suppose for a
Break out.
construction, okay, to build any construction, for example, we can build the houses or we can construct the buildings very easily. First, we need to have some plan, right? First, we need to have some blueprint. Similarly, to design any database, okay, we need to have the ER model. ER model is nothing but it is like a blueprint. It is like a just ఇక్కడ చూడండి స్కీమా డయాగ్రామ్ ఉంది కదా దిస్ ఈజ్ ఎ బ్లూ ప్రింట్ ఫ్రమ్ దిస్ వీ కెన్ క్రియేట్ అ టేబుల్ ఓకే సో ఈఆర్ మోడల్స్ ఆర్ యూజ్డ్ యాజ్ ఎ బ్లూ ప్రింట్ that is what it is used as a backup. Next, object relational data model equal to object based model plus relational model. Okay, object based model enti object oriented features plus ER model. Okay, next object relational data model enti object based model అంటే ఇక్కడ again will be having two ER model plus object oriented features plus relational model. Okay, so object based model. Next, last one is semi structured. The name itself, it is explaining that it is semi structured, not fully structured. Like if you take example as a HTML, in HTML we'll be finding some predefined tags like head, body, title, subject, ఇవన్నీ predefined tags. లైబ్రరీస్ హెచ్టిఎంఎల్ లైబ్రరీ డౌన్లోడ్ చేయగానే మనం ఇవి యూజ్ చేయాలి. బాడీ క్లోజ్, హెచ్టిఎంఎల్ క్లోజ్, టైటిల్ క్లోజ్, రైట్? So whereas coming to data model in terms of our DBMS, in we'll be using XML. What is XML? Extensible Markup Language. Okay. So where we can create our own tags. అందులో ఏముంటాయి? ప్రీ డిఫైన్ ట్యాగ్స్ ఉంటాయి. ఇందులో we can create our own tags. That is what semi-structured data model. So these are the 4 types of data models: relational data model, entity relationship model, object-based model, semi-structured data model. Okay. So this we call it as a data model. It is a collection of tools which displays 4 things: data relationships, semantics, data constraints. Okay. So we are also having other models, but at present we are going to use only the 4: relational data model, entity relationship model, object-based model, semi-structured. So other than this means network model will be there, hierarchy model will also there. At presently not, we are not using that one. Okay. Is it clear?
Clear, madam.
Yes, ma'am.
All of you.
Yes, madam. Clear.
Yes, ma'am.
Yes, madam. Next, coming to the applications of architecture. So there are 3 types of architectures will be available. 1-tier architecture, 3-tier architecture. Okay. What is the meaning of 1-tier architecture is, okay, so where databases are directly available to the user. So what is the meaning of this one-tier architecture means? Example, Google Form. So Google Form or Google Sheet, it is created by a person or a owner that is shared to the others to edit or fill the data. That means what if I want to get your detail means I will be creating one Google Sheet and I'm saying that I'm sharing the link to you so that you will be filling the details. That means one-to-one interaction here. So where the user and the database and the middle all will be present at one place only. So this is used for development of local applications where programmers can directly communicate with database for quick response. Okay. What is one-tier architecture? Database is directly available to the users. Any changes done here will be directly reflected in the database. Example, Google Form. Is it clear? Single-tier architecture. A 2-tier architecture, it is based on the concept of client and server. Generally, 2-tier architecture used in different programming languages like Oracle, Sybase, Microsoft, SQL Server. Okay. So if 2-tier architecture having 2 layers, server layer and client layer. Database architecture having the presentation layer. Example, if I want to open Kite College website means I need to give a in a URL kite.ac.in, right? Yes or no? In kite.ac.in I'm giving means I'm the user using some user interface, nothing but called as a presentation layer, using some mobile or a laptop or some device. I'm giving some URL so that it is redirected to open the page of Kite College. Who is going to give a response? That server layer will give a response to the client that will open or redirected to the page of Kite College. So this is 2-tier, works on the concept of client and server. We are the client and server will be giving response to open the page. Is it clear?
Clear, madam.
Next, 3-tier architecture. So 3-tier architecture consists of 3 layers. Okay, how many layers? 3 layers. Presentation layer, application layer, and database server. So presentation layer is nothing but again comes the concept of client template. Okay, so where client will be giving or user will be giving request to the application layer, where layer will be giving a request to the database. Turn it to give a response to whom here? Application layer. Again, application layer will give a response to the presentation layer so that the page will be redirected. The page will be opened. Okay.
Yes.
How many layers will be there? 3 layers.
Yes.
What are the
Presentation layer, application layer, server layer.
database server? Okay.
Database
So
server.
these are the 3. 1 tier, 2 tier, 3 tier architecture. Okay. Next one is database architecture. This is very important one. Here, if you observe how many partitions are there, 4 partition. Disk storage, from down onwards I'm going. Disk storage, storage manager, query processor. Okay. Disk storage, storage manager, query processor, and up are the users. Okay. Going to see disk storage. Here also again it is having 4 things: data, indices, data dictionary, statistical data. Okay. Data indices, data dictionary, statistical data. What is data? Again, we know what is data or fact data that can be stored or recorded. Where in this block, okay, in this data structure, data is there, right? In this, all the databases are stored here, right? So coming to the next one, indices, index. You know the meaning of index, right? In our textbook, we will find index. What is the meaning of index? What is the purpose of index? Can anyone give me example?